So here's section 7.4, exercise 65. And so I guess I did kind of lie a little bit in class. This does look for a surface of revolution, so let's set it up. Here they're giving us the curve. What is it? Y equals, or no, not y equals, it's an implicit thing. So it's x to the 2/3 plus y to the 2/3. So x to the 2/3 plus y to the 2/3 equals 4. And this thing, I guess, does something like this. We could plot it on Desmos to see, but so a surface of revolution, the only difference is it's like the disk method. Okay, we're going around like that. It's like we're making disks, but instead of the area of each part, we want to take the circumference, okay, and then our element here is actually an element of arc length. So, that little piece is, we make that little piece using that square root of 1 plus y prime squared and a dy there. Okay, so, that's the difference in the formula is that, we're making a little band here, around like that and around like this. And so, if this is the radius r, right, it's 2 pi r to get around, so that's fine. I can do that. That's just if I march here along the x-axis and do this, r will just be x. But this distance here, it's not f of x and it's not x. It's, it's that delta x squared square root plus delta f squared, so the change in the function. So it's, it's that blowing this up, right? Here's delta x and here's delta f, and so, we have this delta x squared plus delta f squared arc length piece that we need for the width of that band. And so to set this up, we're going to need to do an integral from some a to b. We're going to need to do our 2 pi r, which will need to have something to do with x, because we're, again, I think we're revolving this around the y-axis. Yeah, about the y-axis. And y goes from 0 to 8. And, and this is 8 here, and this is 8 there. And so we revolve around that y-axis, so we need our 2 pi r. And then we need this element in there. And so 1 plus our y prime squared and dy. Okay, so we need y prime. Well, the hard part there is, see, it's implicit. So this thing is 2 pi, I don't know why I put a 2 up there, a to b, 2 pi. Now, but if we split this up, this is going from 0 to 8. Okay, so we have 0 to 8. Our radius here is just x, whatever x we're at. And now we've just got to deal with this 1 plus and get our implicit derivative. So, right, we have our y up here. So derivative of x to the 2/3 is 2/3 x to the negative 1/3. And then plus the same sort of thing for y. So 2/3 y to the negative 1/3, and then times y prime, and that equals 0. So y prime is equal to negative, now the 2/3 can go away, we don't need that. So negative x to the negative 1/3 over y to the negative 1/3. And so that's just negative y to the 1/3 over x to the 1/3. Well, that's great now, but I need y then in terms of x. And now the thing is, remember that we square it, right? We need y prime squared. So when I square this thing, I get y to the 2/3 over x to the 2/3 dx. And now the beauty of it is I can tell you what y to the 2/3 is. That's just 4 minus x to the 2/3. So 2 pi integral 0 to 8 of x times the square root of 1 plus 4 minus x to the 2/3 over x to the 2/3 dx. My guess is we're not going to be able to do that. So you just need a numerical integration of it anyway. But at any rate, that's setting it up. So if you had problems with this one, you know, this is what we're doing. The key is building these little ribbons of 2 pi r times that arc length distance. Okay, so that's 65.